Okay. Now notice, is our B bigger than 1 or smaller than 1 here? Jamie, is our B bigger than 1 or smaller than 1?
Bigger.
Good. And so now to find the actual rate of growth for this problem, we're looking for R. I'm going to replace so I could rewrite this equation. I can subtract 1 from each side. And I get that R is equal to B minus 1. So I'm going to replace this B with the 1.18 here. So R equals 1.18 minus 1. My rate of growth ends up being 0.18, which means my rate of growth as a percent is 18%. So I multiply that number by 100. Okay, so my rate of growth for this problem was 18%. The rate itself was 0.18. What questions do you guys have about that? Okay, I'm going to do a little bit of highlighting just to make sure that it's clear. This B value came from right here. Okay. This was B as well. Okay, and that's how we solve for R. We're going to do the same sort of thing with decay. So maybe my example here is y equals 14 times 0.98 to the t. Again, my initial population or initial value is the 14. That's my A value. My B value is right here. We can use our B value to find our rate just like before. So here, I'm going to do a little bit of switching. I'm going to add R to both sides. So I get B plus R equals 1. Then subtract B. And I get R equals 1 minus B. So now to solve for my R, I do 1 minus 0.98, which should give me 0.02 as my rate. And as a percent, I should get 2%, and that's from multiplying by 100. Okay, and again, my B value is this piece. All right, and I used this equation to solve for R, stuck my B value in right there to get my rate and then my percent after I multiply by 100. Okay, what questions do you guys have?
I'm sorry, but for the decay part, can you repeat like the first part right there?
So this part right here. Henry, which part? This one? Henry, which part are you talking about?
That one right there. Yeah,
This
the one.
So this was just a random example I came up with. The 14 represents our initial value, our initial population. The 0.19 is our B value. In order to find the rate of decay from that, I rewrote this equation to solve for R, and then I found my rate of decay was 2.
Okay.
Okay, so I'm going to jump down to the bottom and show you guys what growth and decay graphs look like. So a growth has a B value greater than 1, and a decay has a B value less than 1, but also bigger than 0. You can't have a negative value, okay? And growth is going to look something like this. It's going to get bigger or higher. Decay is going to look something like this. It gets lower. Okay, for growth, you have a plus sign in your equation. For decay, you have a minus sign. And R is always going to be B plus or minus 1. Oh, minus 1, I'm sorry. R is B minus, well, it does depend. B minus 1. Or R equals 1 minus B. So this is for growth, and this is decay. Okay. Now, we can use growth and decay to model different types of scenarios, okay? So in this one, we have a growth model. It says a business had a $10,000 profit in 1990. Then the profit increased by 25% per year for the next 10 years. Write a model that describes this situation, okay? When we do this, I want you guys to identify several things. The final amount, the initial amount, the rate, and the time. Okay? The final amount here is not listed, so I'm going to use Y as my value. The initial amount was the $10,000. The rate was 0.25. They wrote it as a percent. I divided by 100 to get my percent. And my time is 10 years. Okay. So when I write out my model, I'm going to fill in these values. So my F is my Y. My initial is my A value. My rate, so my B value here, since this is growth, is going to be 1 plus my rate. And my time is going to be where that X is, but I'll write it as a T. Okay, so usually this is a T. Okay, to represent time. So when I write this out as an equation, I should get Y equals 10,000 times 1 plus 0.25 to the T power, or in this case, we have specifically 10 years, so to the 10th power. Okay, so we're just like sticking in little pieces corresponding. So our F goes here. Our initial or our A value goes here. Our rate or our B value went here. And then our time goes up here. Okay, so that's how we fill in our equations. Okay, so I abbreviate this, and I'm going to do this in the next sheet we're going through, F, I, R, and T, FERT. Okay, so that's what we remember for each one. What questions do you guys have about the growth model? Okay, if there are no questions, we're going to do the decay model. In the decay model, they already give us the formula. It says the amount Y in grams of a sample of iodine 131 days after T days is given by this particular formula. It asks what is the initial amount of the substance. So the initial amount, we said always goes right here. It's this A value. Okay, so it's the A value over here. So our initial amount is going to be 50, and it was in grams. And then it says what percent of the substance decays each day. So when it's asking about percent, we need to look at this B value. Okay, so we're going to try to figure out what our rate is from that B value. Remember, we're using decay, all right? So we can say that our B value is equal to 1 minus R and then solve for that R. Our B value is 0.92. Okay. And then we can subtract 1 from each side. And we should get negative 0.08 equals negative R, which means that positive R is equal to positive 0.08 or 8%. Oh, you guys can't see. I'm sorry. Okay, so all this stuff we did to solve for the rate. Okay, and it asked for this in a percent. So we had to multiply by 100 to get our percent. Woo! Okay, what questions do you guys have about that? Okay, if you don't have any questions, then we are going to go ahead and move on to the next sheet. I will absolutely post this. I didn't post the solutions with all the colors on it, so I'll repost these solutions with all the colors. There is a solutions document up there that you can go ahead and copy, and that's on Canvas right now. You can go ahead and click that. I'm going to switch to. Okay, so this sheet looks pretty much the same on both sides. The side that is growth has a plus sign here. The side that is decay has a minus sign over here. We're going to start with the growth side. And I know we barely have time left. Okay, so we're going to practice identifying the different parts of the model. Okay, so we have pretty much done this stuff that looks like this. Our initial value is the A value. The rate is R, and your time is T, okay, in the different parts of the model. And it gives us an equation like this, okay? And it asks, what does this represent? It's the initial value. The rate of growth, we take our B value and set it equal to 1 plus my rate. So I have 1.193 equals 1 plus R. I subtract 1 from each side, meaning my rate was 0.193 or 19.3%. And C of 10 represents copper production in 10 years. I know that I'm going so fast through this. I will post the video so you can pause it and go back through as slow as you need. Okay. All right. FIRT is what I've asked you guys to identify for these problems. The F is the Y value. I is the initial value or the A in this equation. The rate is your R and your time is your T. And we're going to do an example with that right here. So it says in 1984, the population of Greensboro, North Carolina was 197,910 people. This means that my initial value, so if I write out FIR and T, my initial value was 197,910. It says it's growing at a rate of 6.9%. So I'm going to rewrite that as a decimal.